Okay, welcome to Lunch with Larry. This is our heavy equipment and energy discussion about design ideation. So how do we create a design? How do we develop that design with the commensurate requirements, risk, different aspects, different perspectives on the design to get our complete definition of what is good design? We're a trusted Siemens partner. We're going to talk a little bit about the Polarian tool today to give you some sense of how these concepts can be implemented in a structured tool. So I'm really looking forward to the discussion and helping you to understand how some of these things fit together. Just to give you an idea of how to get a hold of me, this is my contact sheet, has all my LinkedIn, different information for phone numbers and email. Also, we have this design ideation registration link. That's what this webinar is all about. So if you want to send this webinar series to a friend of yours, feel free to do so. The QR code gets you right there. And of course, if you want to schedule a meeting with me, the QR code on the right is to get a hold of my schedule so that you can get a meeting scheduled. So look forward to talking to you about it. Okay, so major design ideation capabilities. When we talk about how we construct our design, we want to first talk about what is the core set of data. So if we talk about PLM, for example, the core data is the PDM, the product data management, which is really CAD files and a representation of the design that's represented by the bill of materials and how the bill of materials progresses out into the bill of process. So if you don't have the core data in the system, a lot of the ancillary values that you get out of manipulating that data, you can't use those until you get to the point where that core data is in place. So in PLM, it's the product data management, the CAD files. In the ideation part of this, it's really the requirements. And what we're going to do is talk about the core requirements and these different perspectives that we view the requirements with to assure that we have a complete set. What we really want in the complete set is to provide the requirements in such a way as to be sure that they're complete. We want to complete and we want to have a good definition of what is good, what is a good design. So the first thing I always talk about is requirements management, but as we go through this process, I would like you to think about it as sort of comparing notes, where there are a lot of different ways to deploy these systems, a lot of different data models that are involved. Everybody makes a little bit of a different decision about how they want to deploy their system. So this is just one compliant, interesting way to organize the data. We can do different things. Don't be too worried about that as you go through the process. This is more to help discuss the issues and what are the pros and cons of certain approaches. So happy to make changes as it makes sense to you as a company. So when we deploy this system, the core data set, as I said before, is requirements management. So that's the first thing that we want to discuss. How do we decompose the requirements in such a way as to be able to explain to somebody how this design works? Second thing is going to be design verification and validation. So how do we map those requirements into test cases and execute those test cases so we can provide evidence that we comply with our definition of good product? Next one is risk management. And I like to term risk management sort of a negative view of the design. What do we want the design not to do? And what mitigations need to be in place in the form of requirements to assure that that bad thing doesn't happen? So it's sort of a negative view of the design. So we have some data construction to provide us with that perspective. Fourth is standards management, external standards management and internal standards management. And what we do is we develop a set of documents, both from regulatory sources and committees, like industry committees, ISO documents, IEC, sometimes regulation, and also our internal view of how to process those regulations for our device and our design types. So we have a library essentially of how these external stakeholders impact the design, and we want to make sure we map that into the requirements as well. And then finally, we have systems modeling. Systems modeling is sort of the positive view of the design. So essentially what systems modeling is a mapping of the design functions and the functional chains across components of the design so that we can understand how the design is supposed to work. So the positive view. So then we have this perspective of both what we want it not to do and what we want it to do. And in that way, then with these four perspectives on top of the requirements, we have a pretty clear, complete view of what's necessary to make the design work. Okay, why is AI important? And we're going to talk about this a little bit as we go through this introduction, but one of the problems that you're going to run into in the development of a design like this is that there is a lot of work and a lot of detail associated with constructing our understanding of how the design works. And what we really want to do is start using artificial intelligence to make that whole process a lot more productive. And so we're going to talk in the data model about referrals and different ways to construct this so that the AI will provide us with that kind of productivity leverage. And that's really what we're looking for AI to do is reduce the amount of effort or improve our productivity as we go through this process. Why is that important? I'm just going to give you a typical scenario in a moderately complex design for one of my products I've been working on. Essentially, this product has around 250 requirements documents. This is just to give you an idea of the volume that we're talking about. Those 250 requirements documents represent about 15,000 requirements. We probably have in the neighborhood of 250, 300,000 relationships implied in the narrative. So just to give you a kind of a sense, even if we only touch those requirements once and maybe you spend 10 minutes on each requirement, you're still talking about thousands of hours worth of work to get to a place where those requirements can be changed in any way. And in addition to that, when we look at the requirements, you're going to find all kinds of problems with them. We're going to have improper definition of the artifacts. In other words, we're going to call something a spec that's a design requirement or a functional requirement, or we're going to call a system requirement a user need. So there's just sometimes the content that we're putting into the bucket is just incorrect. In addition to that, we're going to have poor processes in that sometimes those requirements will be 2 pages long and they'll actually be 15 requirements in one. A lot of times the requirements aren't testable. We have duplicates. And in addition to that, there's no visibility. So a lot of times these paper documents, they don't have any electronic traceability. So I can't run a report and say, how does this function impact that requirement? Or we have a problem with an error that we've established in risk, and what is the impact of that error? We don't have any visibility because we don't have any automated reporting. And because of that also, the reuse is rudimentary in that usually when people are doing reuse, they're just copy and pasting text from one place to another. And we want to be able to have each one of these logical elements be traceable and be objects in a database so that it's easier for us to keep track of them. All of this leads to many, many gaps in design. And really what we want to do from a requirements management standpoint is get these into structured systems so that we can be sure that we're systematically going through the design. Where does this problem lead? In the bid and tender world, building out of spec is one of the problems that comes out of this. Usually projects have 20 to 30% contingency fees and hundreds of millions of dollars of cost overruns because there's not a clear understanding of how to satisfy the customer requirements in the design and getting agreement that your definition of how the design should be deployed is in alignment with the customer. And so pivoting on these data models from a project management standpoint is really critical to containing the cost of the project. In addition to that, if you make a mistake and you have to change things, not unusual for design changes to take a long time, especially if there's more than one of the products deployed in the field. In addition to that, we have long cycles to try and figure out even what the problem is. So if I want to do an impact analysis, if I'm doing and pouring through documents to try and figure it out, that manual traceability takes forever. And how much better if you can just double click on a report in 5 minutes and get the relationships that you're looking for. These are just a few different ways that the problem can reveal itself. So we want to have a better understanding of the design so that we can kind of pivot and have a clear understanding of how to move the project forward. Okay, so let's talk about requirements management, a decomposition of requirements. This is a really typical model where we start with the user need. They're refined by system requirements, which are refined by design requirements, which are then refined by physical requirements. System and design are typically that area where the device function or the design function lives. Physical requirement is something that the design needs to include physically. So sometimes it's pseudocode, sometimes it's dimensions or materials on the print, but something that needs to be in the design to assure that the design function is met. And once we've identified that physical piece of it, that's built into a part, and the part is constructed, and the process controls assure that we manufacture it to comply with our definition of what that physical requirement needs to be. So this is a pretty, standard decomposition, not the least complicated, but it's also not as complicated as it could be. So this is a nice, I think, middle ground for complex design. But again, lots of different ways to do it. So just to mention, this isn't a workflow. So one of the things that I think that makes people nervous, especially software people, is that when you see a decomposition like this, it implies a workflow in that we would have to do the user needs before the system requirements before the design requirements. That's really not the intention here. All this is a decomposition of the design so that when we go to explain how it works to somebody, we have have a logical construction that it's easy to walk people through. So we need to have this decomposition in place when we're finished, but there's nothing that says we can't fill out design requirements before we do system or, user needs before we do physical. There's no need or requirement that we do those things first, but I think at the end of the process, we want to be able to explain how it works. And that's really what this is about, is design decomposition, not about workflow. So the first thing I want to say almost always when we talk about building out design ideation on the front end is if you don't have a system that's a structured system like this for requirements, full stop, it's the first step. We could do a 2 to 3 week install, and I've seen cases where we have better than 95% reuse, and frankly, that pays for the system. We don't need to go any further, get any more complicated in our data models and how to manage things. Just put the requirements in place and you're going to be happy for the process. So just to make sure that we understand, this doesn't need to be any more complicated than this. We could just put the deconstruction in place. We have templates around this and we can execute and move you forward, get you some real value. Also, when we talk about, I'm going to just mention these as we go through. When we talk about the data model, this is a great place to use artificial intelligence to inform the model. So whether we use a systems model to create the requirements, or we just build these requirements from structure and from the unstructured data that we have in the form of documents, we can use AI to greatly improve the productivity of getting those language narrative-based requirements built into the system. So this is a great use case for AI, mainly because it's 100% focused around using a large language model to deconstruct and compose recommended requirements. So this is a great place to start with AI. Speaking of AI, what are some other use cases? And I'm going to talk about these as we go, but generation of requirements is one, but another one is taking the requirements and generating test cases. Now, when we talk about AI, I think one of the things that people don't understand typically when they get into AI is that the prompt has everything to do with the quality of the output from AI. And so what we want to do is improve the prompt. Well, how do we do that? Do we teach people how to better type in what they want their prompt to be? I think no. I think what we do is we train the agents with the device data, the ideation data that we've already constructed. And then we use that data to move the data construction forward, which becomes more robust as we check it and move it into the data model. Then we can use that data model to take a next step. And so the nice thing about this is it greatly improves the prompt. So the context of the data that's already in the system provides the AI with a much better understanding of what we're trying to accomplish. So that's a really important part of it. But also it works on the whole file. So it's not this localized view of AI where we're saying, I'm going to create 5 test steps in a test case. Can you give me the 5 test steps? No, what we're doing is we're saying, here are 15,000 requirements. Create me a test case for all of them. And you can imagine that when we start taking that broader view, that the productivity impact is much, much greater, 2 orders of magnitude greater than if we're just doing it one at a time. So these are just examples of this broader sense. So development of the test cases is one, the risk management FMEAs, importing of external standards, creation of the systems model, or creation of the requirements. So either way, either creation of the systems model from the requirements or creation of the requirements from the systems model. Traceability to the parts, that's another great example. So these are all ways that we can use the model and use AI to try and improve how much time it takes us to build out these sort of significant data models. Okay, so when we do bid and tender, essentially we have 3 levels. And as I was saying before, we have these stakeholders that are outside the company, call them regulatory bodies, maybe external standards that we need to be compliant with. Those are built into a library and essentially provide us with an understanding of what we need to build into the design. I'm going to call the second level process companies. So chemical, nuclear, upstream, downstream in oil and gas. These are process companies that have need of equipment to do something in their business. So those are essentially the equipment users. And then what we have are equipment suppliers. In oil and gas, those are EPCs, but in any case, we have people that are out there, companies that are out there building equipment, large, complicated pieces of equipment to supply the processes that the equipment users need. So we have kind of these 3 different levels. And if you think about those 3 different levels in context of the requirements decomposition, at the top level, we have standard requirements. These are just requirements that are coming from the outside. We have the user needs and system capabilities that the process companies will define. And then we have requirements, which are the engineering translation of the user needs, which the equipment suppliers will be building because they're the ones that are designing and supplying the equipment. So when we do this kind of composition, all of those elements are in the Polarian application. And what that allows us to do in Polarian is manage the process, sort of soup to nuts, end to end, and be sure that whatever we're supplying from an equipment standpoint satisfies both the equipment users and those external stakeholders. And having this kind of a construction is, I think, really important to providing us with an understanding of how to holistically satisfy all the stakeholders in the program. So this is just a design report in Polarian to give you a sense of what this kind of reporting looks like. So essentially, we have this first tier company, which is the process companies. They supply the user needs. What is it that this piece of equipment needs to deliver? And then the next three levels are supplied by the equipment and build supplier. So the system design specifications, or physical requirements, those are defined and tested by the equipment supplier, and they're direct satisfactions to the user need. So not only can we get agreement up front that the way that we're going to satisfy this user need is in this particular way, but also we have all the test data and the test cases that are set aside or linked to each one of these requirements to show that we complied with what we defined as good when we started. So that really brings up test management. So each one of these requirements in each of the levels then would be assigned a test case. Test case would be executed against a part or an output, right? A part that is the device under test that's going to be used to assure that test case is met. So the test case has test steps. We execute those test steps with the output that's assigned and get a test result. Now, in Polarian, we have this ability to do this. This is the test management capability. And what that test management capability does is wrap all the evidence and our assurance that we complied with our definition of good into the data model. And really important, because not only do we want to know what the design needs to do, but we also want to have in the traceability the fact that we assured that it does what it needs to do and that we have that evidence baked into the system. Now, from a use case number 2 standpoint for AI, you can imagine now that I've built out all these requirements and the requirements are now constructed properly in that they're testable, it becomes relatively simple for us to say, okay, here's what we need the thing to do, and give us 10 test steps that are necessary to assure that that result has been met. So we can create all these test cases in one go. And that's another really good use case for AI. So again, we go back to this design report. Now the 5th column is the test case. And as we define those test cases and link them to the requirements, we'll get the test results. So that's this traceability in the report that we can provide any kind of view of the data. So if you wanted to see the test results here, we could provide them. If we wanted to, show what parts we're using, what revision of the parts, all that data is built into the data model. So anything that you want to see in this report is really available to you. Okay, so risk management is the third perspective that we're going to put on the design. So again, we start with this core requirement set. I kind of want to come back to that, because if we don't have the requirements in the system first, then risk management it doesn't really make any sense, because essentially what we're going to do is we're going to analyze each one of these requirements for how it can fail. And then the next level down of requirements is going to be our mitigation strategy to assure that the higher level is met. So essentially what we're going to do is put into the traceability then these FMEA reports. And what the FMEA does is it analyzes the errors for root causes and then supplies a set of requirements that are the mitigation to those root causes so that we can assure that the system requirement at a higher level is met. So if you bake these in, what happens is the FMEAs have a place in the data model. So as you do your FMEA activity, you're enhancing your requirements and making them more complete. That's really what this is all about. In our risk management session, we're going to talk about this in more detail, but this is a really nice way to enhance and improve your requirements over time. Third use case for AI here is to use it to help us construct the error model and the mitigation strategy for failure of any particular level of the requirement. So that's another nice use of the tool. External standards management, second to last here. The external standards management, what it does is it takes in these external standards, breaks them down by clause, and then maps those clauses into a normative library. And the normative library is our internal SOPs on how to do design for a particular product type. And so we have a view of how we're going to apply those external standards for any particular design type. So if you're doing, I don't know, a wellhead, for example, you have external standards that are associated with that, and we have an idea of how we want to apply that. Well, that normative library then becomes our standard document for how we want to deploy wellheads for the 15 designs that we have in the field. So we have this atomic traceability between the clause and the requirements to show how this type of product is going to show compliance to that particular standard. So once we do that and we have the internal library, we share that as a document down to the project, and then we make whatever changes we need to at the project level, trace those requirements into test cases, and have the test evidence. So this is how we show that the project, any particular project, is compliant with the external standard, because we have this 3-level traceability back to the standard. And with it carries the test cases and the test results, so that we can actually just run a report, double click, say we want this external standard and that project, and it'll show the compliance of the project to the standard with the evidence that we are compliant, which is great from a regulatory standpoint. If we have a regulatory body saying we have to be compliant with some external standard, what this does is it bakes it into the data model so that we can very quickly show that compliance. And by the way, not only show the compliance, but we can keep the external standards updated over time and show what needs to be done to any particular project to bring it into compliance with a new revision of the standard. And so it's also this mechanism for keeping the projects updated over time. And we'll talk more about this in detail, but this is a great way to build out the system. And again, from an AI standpoint, one of the great use cases here is the import and update of these external standards with Polarion as a traceability tool. So that's another really good way to use these large language models to import a PDF, break it down by clause, and then update it over time and compare those clauses and keep this document that's inside of Polarion updated. So great use case for AI. So the final perspective is systems modeling. And when we think about systems modeling, what it really is a mapping of functions, design functions. So if you think about the function as a black box, we have inflows to the function, we have outflows from the function, and the function itself is a transformation. So what is the outflow? How do we define the outflow? And the answer is with a requirement. So the requirement characterizes what that outflow needs to look like. If we characterize all the outflows, we've then verified that the black box transformed the inflows in a way that made sense to our definition of what the outflows need to look like. So in essence, we've said that the function does what we expected it to because the outflows have complied with our definition of good. So from an AI perspective here, we can either drive the systems model from the requirements definition, or we can drive the requirements from the functional outflow definition. And so this is another thing, as we build out the data model and understand the context better, we can use it to inform the next step, whatever the next step is. So before we leave, I want to talk about the complete picture and then what is this end case, right? Where are we trying to drive to? But the system model or this data model, essentially we have the requirements, we have then the negative perspective of the risk management. We have the positive view of the design. What does the design need to do? That's really the systems modeling piece. And then finally, we have traceability to the test cases, the test results, the external standards, and the parts in the design. So what is the bill of materials of the parts? What's the configuration management of that bill of materials? That's a really important part of the traceability as well. So this is the complete data model. And from that, we're going to get something that's really interesting. So I'm just going to give you, when we have this traceability in place, one of the use cases, one of the really nice outputs of this kind of a complete construction. And I think it'll give you a better sense of why this is important. Oh, of course, AI use case number 6 is traceability to the parts in the PLM system, and providing recommendations as to which parts would be the best ones to link to any particular requirement or requirement level. Really nice potential use case there. Okay, so where's it all going? I'm going to give you this example of the design completion report. How do we define being done? What is the definition of done for the product? And how does that relate to the part or output traceability? So I'm just going to run through this quick so you get a better sense of it. So when we do traceability of the requirements, this is pretty typically what we see. We start with this decomposition of the requirements. So this in and of itself is valuable, but it leads to the next question, which is really, how do the test results trace into the report? So the way that's done is we define a test case and we execute the test case against the definition of good, which is the requirement. Well, then you ask yourself, what test result are we looking at here? So if I execute this test 20 times, am I looking at number 1, number 5, number 20? Well, default, when you do this kind of a report left to right, what you're going to find is it's the last test. So of course, what that begs the question is, okay, well, which part was used in the test? And so the next step here is to take the part and define the part number in the PLM system that traces to the requirements so that we understand what is the device under test that we use to assure that this performance characteristic is properly designed. So which outputs or which parts are we referring to? And what I mean by that is the parts have their own configuration management. They have their own revision level, and the SKU that we're going to be shipping has its own set of revisions for all the component parts that are part of that SKU. So the next thing we need to know is what's the revision of the output that we used. So not just what was the part, but what was the revision of the part. So in this kind of a report, what we're really doing is driving it left to right. We're saying, start with the user need, give me all the system requirements, design specifications, then all the test cases, what are the test results, and what are the outputs that are associated with the test. So we're kind of going left to right in the process. Really though, is that what we want? I think what we want is to understand and drive this from the SKU that we're going to ship. And when we do that, now what we're saying is, what is the SKU? Give me the part number of the high level assembly and the revision so that I can pull into the system all the parts that are associated with that SKU and then back into it. And so what this allows us to do is drive the results from right to left. So the first thing we do is we establish what is the SKU we're after. That gives us all the parts and the revisions of the parts. And then what we want to do is associate that with the requirements management, not the other way around. When we do that, what we're going to find is we get a very, very different report. So essentially the top level here, I'm just going to go through these different scenarios. If we have the same revision for what's in the SKU versus what is in the system or the last tested part, we're going to get this A to A revision. And if we have a good test result, we're going to get a green in the box, right? So that means it all aligns. We have the same revision of the part that was used as part of the last test or part of a test, and we have a positive result. So therefore we have this green light, we're good to go. But we're also going to have situations where they're unassociated. So we either have a part in the SKU that doesn't have a test case, or we have a test case that doesn't have a part. In that case, we have to correct it before we can say that the part's ready to ship because we haven't tested it or we don't have the evidence that it's been tested. Next one is oftentimes we're going to have down revisions of things. So either the current SKU, in essence, the current SKU requirement we're not going to have a test that's associated with that revision of the part. So if that's the case, then we need to get a new test run against that revision of the part so that we can see whether we have a good result or not. And then finally, we have the same revision, but the test failed. So as we go through this report, what we're going to find is that there's differences. And you notice that the test results, the last test result, which is the column to the left of the red box, right? Those aren't necessarily the same because that last test result might be done against a different revision of the part or a revision of the part that's not included in the SKU we're trying to ship. So we really need to start and drive the process right to left, not left to right. And I can't do that if I don't have all this traceability in place. None of this reporting is possible if I'm trying to do it with documents because every one of these columns is a document. And a lot of times a column might consist of 30 documents. So trying to figure out what these relationships are takes forever. And it's going to be inherently wrong. So very important that we build this into the data model. So finally, when we're done, this is my definition of done. This report would say test pass 100%, and we'd have a green check mark in the SKU status. And the workflow of just going through this report and double clicking on each line and making corrections and doing testing as we go, you can imagine how much faster it is than trying to do this manually. So just to give you a sense of why is all this traceability so important, this definition of done report where we're tracing to the SKUs, I think is a great illustration of that. Are they aligned? That's really what we're trying to understand. Okay, so this is our introduction. We have the requirements, verification, risk management, standards management, and MBSE. Next week, we're going to talk about V&V and look forward to our discussion next time. So thanks for your attention this time around. We're looking forward to working with you in the future. So there's my contact information again. Feel free to scan the code and send the registration link to a friend. We'd love to have as many people on the call as makes sense. So thanks for your time.